Hello everyone, I am Shivam Rao. Will be presenting my portfolio presentation for the directed research project in this YouTube video. This project is guided by Dr. Jyoti Trivedi from CEPT University and Mr. Surat Sontake from We Construct Private Limited. Here we will be focusing on the introduction part for the topic titled 4D for safety on construction sites. So the problem statement here says there are serious injuries and accidents due to underestimation of safety on construction sites that has been observed. While our aim is to identify safety features and parameters which can be incorporated in the construction project using BIM and visual planning technology. The objectives are to reduce risk of injuries, increase productivity, ensuring transparency and improving the communication. The outcomes of this directed research project are anticipated as an 4D animation video which will be compared with a site example, and the differences will be then observed in the conclusion part. The research methodology for the study is given here. It starts with the review of literature, then reviewing the safety standards around the globe including the OSHA guidelines, then capturing preliminary awareness regarding the BIM and visual planning aspects for considering the safety domain, while parametric Revit family modeling is the next step, and then there will be a pilot project that will be modified as per our directed project. Then there is an integration of BIM and Synchro 4D Pro software. Finally, an 4D animation will be developed from Synchro Pro for the visual planning of the real construction sites. A literature search strategy was developed for conducting the literature review. Here, the search strategy had first initially searched based on the keywords, then the abstracts of the articles were filtered, and the final text concluded with 39 literature papers that were reviewed and the outputs were generated. The learnings in a brief suggested that there is a strong visual simulation and working environment help is being provided by the BIM around the construction sites. Early recognition of hazards and unsafe conditions is one of the premier feature of BIM on the construction sites in terms of safety aspects. While BIM is still in the early and premature stage in India, it lacks interoperability with several other technology and standards. While the increasing use will be definitely helpful in terms of protection for the workers on the site in adverse conditions, and this will increase the safer conditions on the site, reducing the construction man hours lost. While the research gap identified was there were a number of articles discussing applications for use cases in terms of construction safety, but many studies incorporated other models and other simulations, but the studies on preventive measures in terms of clearance objects or objects centric towards safety were not identified. While the substantial number of articles using BIM applications for construction safety were observed, this shows a growing trend for literature and research of BIM application in construction safety. Here we will go through these articles in the next slides. The next step was data collection. Here, two methods of data collection have been used. First is the primary data collection, where semi-structured interviews with subject experts in terms of health, safety, and environment were conducted. A questionnaire survey study was also developed for this topic, and the profile of the respondents is as given in this slide. While four experts were interviewed, two of them were from leading construction companies, and one of them came from the consultancy of an EHS company. The secondary data now we move on to was collected from guidelines around the globe, including OSHA guidelines, HSC UK guidelines, ILO, ISO guidelines, and Indian standard codes. Coming to the data analysis part, here we have made several guidelines as in standard reference for developing clearance objects and safety parametric families for the construction equipment on site. On the left hand side we can see the guidelines which are used and in the bracket we can see the equipment that are following those guidelines. Here the site equipment and site vehicle families are shown in the form of screenshots. Here in the site vehicles that are shown in the center, including the trailer trucks, here we can see some red clearance blocks. Those are based on the guideline of IS code 7293, while the boom placer of placing used for the concrete works has been showed. Here the guideline is based on an indigenous guideline developed by the study author. It shows that the clearance ring provided around 29 feet covering the equipment length. On the right hand side we can see one of the cranes, that is the tower crane commonly used on construction site. It uses the OSHA 3433 guideline. Here we can see whenever we have a change in vertical degree of the crane, we can see the dynamic safety parametric clearance radius is modeled such that with a change in angle we can have a change in the clearance zone as well. Here also we have shown an fall protection zone. Fall protection zone here covers the lifting area or lifting zone, which is supposed to be a safe zone for the construction workers. And similarly other families are developed and more precisely given in the additional work video that is linked in the portfolio. Continuing the data analysis part, here we can see a better picture of the equipment Revit families and one of the safety centric object that is modeled for the ladders. So here first is the personal hoist equipment family with the interior clearance of 8 feet and the exterior clearance of 10 feet around the hoist cabins. The second is the concrete pump equipment that has a clearance of 0.6 meter or 1 feet 11 inches nearing to 1 feet 12 inches. Now the ladder family, based on the guidelines mentioned in the last slide, here has a caution area and some cone variegating provided. These equipment families are also loaded further in a pilot project which will be explained in the next part. Here in this Revit sample project we have loaded all the families that were developed. Let's have a quick lookout for all the families that have been developed. Here we can see the site equipments that are shown. Here we can see the ladder families that are developed, the concrete boom placer in the employed position and at the stationary position. Here we have the loader equipment, the material hoist equipment, the concrete pump and the dozer equipment. On here we have the complete set of the all-terrain cranes which were modeled. So these are of different XLs. So let's say starting from 2 number of XLs till number of 9 XLs we have modeled the all-terrain cranes. Here we have the crawler crane used in the superstructure work. Here we have drill rigs that have been used in the substructure work. So 3 positions of the drill rigs have been modeled. Here we have this tower crane family that was developed with the fall protection zone. Here we have the forklift, 2 types of forklift truck and the forklift, the dump truck, the concrete truck and the excavator that has been modeled. Here we can see the safety nets that were developed as the part of the study. So this is a sample project where all the families have been loaded, which will be further used for the other pilot project. The next part includes the 4D visualization. Here the developed Revit parametric families for the safety objects around the equipment have been loaded into a pilot Revit model that has been used for this study. The inputs here are the pilot inputs for the pilot study includes the Revit model, the Synchro 4D Pro files and the construction schedule. So the process here is to modify the model for generating the 4D visualization output, integrating the BIM model and Synchro 4D Pro, and the final output will be as an animation video. Here the modification involves developing several worksets including the substructure workset, superstructure workset and the landscape workset. In the superstructure workset, here we can see the concreting equipments like concrete truck and pumps. For the substructure workset, here we have added the drill rigs, the luffer cranes and the excavator. On the landscape workset, we have the dozer trucks and the dump trucks which are used for the hardscape and landscaping works.
Project Revit model has been modified to develop certain views that includes the logistic views which have certain families which are used for logistics and substructure purposes that are modeled and shown as in this view. The next one includes the structure view that has the superstructure elements that are presented in this. So it includes the cranes, the concreting equipments and other files. Here we can see we have also incorporated the fire extinguishers in this. So once the modeling is done, we have shown the fire extinguishers in this model. Here we can see the rings and the zones denote the placement of fire extinguishers. Here we have the complete set of fire extinguishers on each stories that is provided. Now we'll switch to one another view, that is the hardscape and landscape, which includes the roadworks material, include the dozer part, and the several cars have been represented for the visual purposes of the project. It includes the dump trucks, and these are the separate views created for this project. And the complete model looks like in this manner when all the views are combined together, apart from the hardscape and landscape views. So this includes the architectural view and the structural view.
The next step after modifying the pilot project in Revit is to link it with the synchro file, and in the synchro we have to follow these three steps. It includes setting the appearance profile for the equipment families and other objects while assigning 3D paths in synchro to make an sequence of movement, and that is done via assigning this 3D path. Here the last step is to generate an animation output video which will be having the settings as shown in the screenshot of Synchro. These three steps will help to develop an output of an animation video for the construction project that has been used for showing the pilot safety families in this study.
Here the project synchro file has been presented. Here we can see the project is at the starting phase. Now we'll show the different families as we have loaded at different stages of the project. So here we can see the dozer family, the dump truck families will be coming, and such families are loaded in this project during the safety monitoring part. Here we can see the excavation work has been started, and these are the excavator family that have been loaded in the model. And similarly for other stages of the project, we will be presenting in a short manner what all other families were loaded. So that includes the concrete pumps and the concrete truck families. This includes the safety centric tower crane families with the visibility models. For representation of how both tower cranes will look different with and without safety parameters, here we have shown one with the safety parameters in the red colored ring that is surrounding the tower crane, while other one is without that safety parameter. Here we can see as the stage progresses, we can find other families coming into place. For the superstructure work in the facade for the building, the crawler crane has been used, and here we can see it has interface or intersection in the operation radius with the help of the power line. So this ring helps the workers to avoid certain clashes. And finally, we would like to present the output of this whole pilot project, and here we can see certain movements for the dozer, and the dump trucks are left out because they are employed for the landscape and hardscape works. While this will be the final output for the project, here we can see the complete model of the project that was developed in Synchro 4D Pro.
The Synchro 4D Pro animation video was generated, and in this slide we have shown the several instances in terms of screenshot. These are captured at several key milestones of the project, including construction start, structure works start, hardscape, landscape works, and at the construction end phase. Here, the comparison of safety features in the pilot project model with and without parametric families is made. The first instance has a tower crane which is loaded with the clearance zone around, which helps to operate it safely without encountering any power lines which are in this case present near the site project. While the other case is of safety net that is provided in the project and another model doesn't have the safety net. The third instance has the fire extinguisher that is provided with the protection area, and here we can see the similarities and the visualization of this project model with and without the safety families. This helped to reduce the safety loss time and the man-hours that will be affected. In turn, it can reduce the time and other safety features can be enhanced while the likelihood of accidents and injuries can be reduced on the job site. The study has certain limitations and the key learnings are summarized here. The limitations include there are less guidelines developed for each and every construction equipment, the absence of HSE professionals in the questionnaire responses, the validation of this parametric families in the industries where it is used. One of is the interoperability issues for Revit software. Overall construction safety could have been focused more. The time consuming export of animation videos from the Synchro 4D software. While the learnings include BIM offers visual representation of site workplace, increasing awareness of hazards before execution. Safety parameters for operation of construction equipment including standard zones and fall protection measures were developed. Study developed parametric Revit families for construction equipment and site objects. And a 4D visualization animation video was developed from Synchro. Incorporating these families in the early phase of the project can include efficient construction processes and reduce the likelihood of accidents and instances. The future scope includes expanding this scope of Revit families for other safety parameters like PPEs and all. The integration of Synchro 4D for Unreal Engine, which enhances the visual effects that are nearly equivalent to the on-site conditions with the help of Unreal engines, and certain other plugins can be added on which can help the managerial stakeholders to get more about this project and such studies, while enhancing site safety with ML analysis to predict what type of construction accidents or injuries are most observed on site. The enhancing safety awareness with VR in construction to train the workers with the help of training tutorials developed in VR. This will be the conclusion for this summary of the study. Finally, I would like to thank you all and appreciate your time and efforts for reviewing this YouTube video. If you have any further feedbacks or any suggestions, please feel free to drop in the comments or to mail us at this email ID. Thank you all. Have a good day.